joining us here today. You really should be clapping and congratulating yourself for the long walk that you took to get here. We really appreciate you coming. It's good exercise for all of us, so thank you. We have a great day today. My name is Vito Mabruco. I'm from the NTT Corporation. Sorry for the big picture, but I'm very happy and proud actually to be your MC for today. We have a jam-packed agenda where we're really going to be covering a lot of ground, discussing leading-edge technology for the next infrastructure for networks and computing. And this is really the future for this infrastructure, which will be secure, sustainable, and scalable. And this is really for the future for all of us as we see AI becoming more and more part of our lives and our businesses and our governments. So today we're going to cover a lot of ground, including technical, but also talk about new value opportunities that this type of technology can bring everyone. And this is very important to businesses and society going forward. We have a jam-packed number of people, top executives and SMEs, a number of doctors and PhDs, and very, very smart people that are going to be here speaking today with you. So let me talk the agenda. As you can see, we'll start with the executive viewpoint of a number of our board members from the ION Global Forum. And then we'll take a break and have the first panel, the new norm for data centers. And then we'll take a very short break for the second one and increasing the ROI for 5G and beyond. Now, I just want to cover a little bit of housekeeping and maybe some interest for you. First of all, there's some social handles if you want to do any kind of Xing or whatever it's called now, and tweeting or in LinkedIn, YouTube. Also, I invite you to visit our new website, iongf.org. And on that site, you can find all kinds of content and videos and reports, which I think will be very interesting for you. And also, we have this year, this is the 5th year of the ION Global Forum. So we're very happy to be celebrating that this year. And with that, we're going to have an event in Stockholm in April of 2025, where we have an event that is open to non-members as well, where we're going to discuss a lot of different technologies. We're also going to have a market landscape discussion, so we're welcoming anybody and everybody to join us in Stockholm. And then the one after that will be in Dallas, Texas. Also at the end of March, we'll be at the OFC in San Francisco. So if you have time and you're in the area, please join us there. NTT actually has an experience center right across the street from the Moscone. You can drop in to say hello to us as well. Now, the ION Global Forum has a booth here for the first time ever, and I've been there a few times, and it's got a lot of traffic and a lot of interest. So you can see, after 5 years, we're really starting to get that interest that the ION Global Forum can deliver value to the industry. So come over there. You can meet with some of the executives. You can meet with other members, and we'll even give you a Belgium chocolate if you show up. So please do. Now, we're going to start the afternoon with the executive viewpoint. And I'm very pleased to introduce our first speaker, Dr. Kawazoe from the NTT Corporation, Senior EVP CTO, President and Chairperson of the ION Global Forum. Please welcome Dr. Kawazoe.
A world with minimal energy consumption, progressing technology, and protecting our environment. For the first time in human history, both are possible. Not humanistic innovation, but innovation from a broader perspective. Not predicting the future based on the present, but reconsidering the present from the future. Here is our answer for a better future on Earth. ION Global Forum. Innovative optical and wireless network. It is a new information society infrastructure with technology that is entirely different from the current information and communication technology. In the past, processing was only possible within the boundaries of human perception. With ION Global Forum, it can go beyond our human potential. We will be able to exchange information in real time and make predictions for the optimal future. By connecting the virtual and real world, we can enable smart city applications that aim to perform autonomous control beyond human cognitive abilities. We will lay improved countermeasures for natural disasters and optimize energy and mobility. In a world where AI becomes an essential part of our daily life, it will be possible to realize human-centric applications that assist and enhance communication by incorporating AI. This technology will be incorporated across the spectrum, from interactive live performances, cloud gaming, specialized learning, autonomous driving, to smart manufacturing. Numerous entities around the world have expressed high expectations for ION Global Forum. Widening disparities and social disruption. Also, unknown risks to our health and infrastructure. We're no longer able to solve problems solely based on past data. We'll create a global infrastructure that embraces diversity and makes everyone around the world happy. Nobody gets left out. To achieve this, the world needs a new evolution. For the next evolution, for the next world. ION Global Forum.
Hello, everyone. I'm Katsuhiko Kawazoe, CTO of NTT Corporation, and also President and Chairperson of the ION Global Forum. Thank you so much for coming to the ION Global Forum session. As Bito-san mentioned, 5 years has passed after we established ION Global Forum in 2020. I appreciate all of you for your cooperation and understanding. Thank you so much. Okay, let's start. Now we are facing many crises, such as COVID-19, climate change, natural disasters, and divided world. We have to enhance ICT technologies more and more to solve them and forecast the next crisis as soon as possible. Looking back through recent history, industry's emphasis has shifted from quality to quantity. And now the real space will merge with a virtual space, and value will become more important. That is friendly to each culture, people, and the earth. A new communication infrastructure more closely linking the real and virtual is needed. But this is a big challenge, I think. On the other hand, internet traffic is growing exponentially. Therefore, a lot of computers are used to process large amount of data. As a result, energy consumption is skyrocketing. However, carbon neutrality is a global goal. In short, we must achieve both economic growth and a decarbonized society. To solve the problem, we focus on optical technology. Optics has a wonderful advantage compared with electricity. Even if the transmission distance or frequency increase, the power consumption barely increases. We currently use optical fiber for transmission. On the other hand, it has been difficult to apply optical technology to information processing for a long time. But in 2019, we finally succeeded to invent the world's first optical transistor. This innovation was the origin of ION. ION stands for Innovative Optical and Wireless Network. We, the ION Global Forum, aspire breakthrough innovation beyond limitations by ION. ION is a next-generation optical-based communication and computing infrastructure, and it consists of a variety of technology elements. Performance advantage of ION are 100 times higher energy efficiency, 125 times higher transmission capacity, and 1/200th end-to-end latency. Advantages of ION are variable for large-scaling AI. AI has evolved tremendously in recent years. It is said that training AI model at GPT-4 scale requires about 40,000 megawatts hour of energy. This is equivalent to the energy generated. This is equivalent to the energy generated by 40 nuclear power plants. Sustainability is a critical issue for AI evolution. I'd like to talk two proposals to overcome this issue. One is distributed data centers, and the other is compact AIs and their constellation. First, let me show you a video about distributed data centers with ION All Photons Network. Please watch this video.
As society becomes more data-driven, the demand for data centers increases. But two challenges stand in the way of building new facilities. The first is the lack of land inside cities where data centers can be placed. The second is that data centers installed in the suburbs where land is available lead to high latency and low network performance. The All Photonics Network, or APN, will solve these two issues. Conventional networks require photonics-electronics conversion of optical signals to electric signals for each optical line, which leads to unavoidable latency problems. APNs, however, do not use photonic-electronic conversion, resulting in high-speed communication delivered through optical technology. APN-equipped data centers will not be affected by communication delays due to facility location, like today. APNs also consume less power as they only process light. Plus, promoting the dispersion of data centers in suburban areas will result in the consumption of local energy. ION's mission of contributing to a data-driven society while remaining carbon neutral will continue on.
Thank you very much. The other proposal is compact AIs and their constellation. AI constellation connects small-size, lightweight AIs specialized in a specific expertise to communicate with each other. Most present AIs are singular massive AI. Do you know, perhaps generative AI can do almost the same, but only one thing they cannot do. Do you know? So they cannot deny the answer. Okay, so we want to propose other approach to using AIs. Okay, AI constellation can find a truthworthy answer with democratic manner by demonstrating their own expertise. ION can realize perfect synchronization between AIs for superior performance. Okay, then let me talk about training data for AI. Very important issue. Current generative AI use large language model developed with data created by humans. So current AI is limited within human world. To expand the limitation of current AI, I believe AI should understand not only data created by humans, but also various data on the Earth and in the universe. We call it world model for the next generated AI. One of the use case for world model is AI for mobility. We will build a mobility platform with AI model by learning from the diverse data of people, mobile sources, and infrastructure. The internet is not enough for this platform due to the lack of efficiency, capacity, and latency. Toyota Motors and NTT started a joint initiative toward creating a well-being society using ION. Toyoda-san, thank you very much. Okay, our ultimate goal is to go beyond the real world, utilizing unlimited innovation ION. Expo 2025, Osaka, Kansai, Japan, opens next month. You can experience such an exciting future. ION will strongly support Expo 2025. I'd like to give you a glimpse of what kind of experience awaits you. Please watch this video.
In 1876, the telephone gave humanity a glimpse into the future. In 1900, people saw the dawn of a new century defined by visual media. In 1970, wireless communication began to redefine connection for the world. And now, in 2025, a pavilion where time and space intertwine. With the next generation communications infrastructure, ION. Spatial transmission technology will transcend distance, merging distant places into one shared reality. A future where distance dissolves, spaces unite, and presence is felt. Welcome to the next era of communication.
Thank you. Finally, I'd like to introduce today's agenda. As president of the ION Global Forum, I'm very happy to have such great leaders on the stage with topics related to data centers and 5G business with ION. I hope you will enjoy our session to the end. Thank you very much.
Thank you, Dr. Kawazoe. I'm always impressed with the breadth and the depth of your presentation. It really evokes a lot of emotions, but it's also based on a lot of facts. So thank you for that. And thank you for the leadership, both at NTT and the ION Global Forum. Appreciate that. Well, let's move on to our next speaker. And this is Chris Wright from Red Hat, CTO and SVP of Global Engineering and Board Director of the ION Global Forum. Please welcome Chris Wright.
All right, so welcome. This is really an exciting moment for us. As you heard, we are just celebrating our 5th birthday. So let's just make a little noise for number 5. Yeah. And maybe it's a coincidence, maybe it's not. This room is at full capacity, and we are 5x oversold. So maybe that's because it's our 5-year anniversary. There's clearly a lot of interest in the work that we're doing at the ION Global Forum, and certainly wanted to say thank you, Kawazoe-san. Always enjoyable to see what you have to say, and giving us this vision that we're driving towards to build a more sustainable, smart future for ourselves, leveraging all photonics networks and the innovation of optical and wireless networks coming together. So this, to me, is what I'm excited about. It's why I'm involved. It's building this smart, connected future world that I think, really, I hope we all want to be a part of. So having spent the last 5 years working together as a global forum, growing, increasing our membership, increasing our focus areas, we've established the vision. We have some great proofs of concepts and technical building blocks. And so 5 years in, we're starting to transition to how do we see this becoming real? How do we build market awareness and start the beginnings of this journey, which, as you've heard, is a long-term journey with some very audacious goals. In this picture, you can see some of the different areas that we're focused on within the ION Global Forum. And self-serving, you can also see where Red Hat fits into this picture. Now, I would imagine many of you are wondering, what's Red Hat's connection to photonics networks? We're not known as, say, an optical network creator, but our focus really has been in the open source space, working on platform technologies, things like Kubernetes in our Red Hat OpenShift and Linux in Red Hat Enterprise Linux. These same platforms come together in this picture to help enable what we call DCI, or data-centric infrastructure, bringing computing and network resources together across this all-photonics network. So our expectation, and I know you would all see this as well, our future has a lot of AI in it, and AI has a lot of open source in it, whether it's the low-level tools and frameworks or the licenses for the models themselves. This is a key part of our collective future, and from a Red Hat point of view, this is where we're putting our focus in bringing AI to Linux with RHEL AI, and bringing AI to distributed systems with OpenShift AI. Our belief is that this data-centric infrastructure really benefits the generation and then pushing into production of AI in a way that we can't exactly do today. So one example is the ability to increase scalability through building composable systems built from disaggregated components. So pools of resources like CPUs, GPUs, DPUs, IPUs, memory, reconnected and dynamically built to support a specific workload. And this is something that we're already capable of doing today without relying only on all-photonics networks with today's technology to dynamically create a Kubernetes worker node with the OpenShift container platform, and it's some of the work that we've showcased here in the ION Global Forum. Together with many of our partners in the ION Global Forum, we're designing this data-centric infrastructure, not only for AI platforms, but there's other use cases. The combination of cyber-physical systems and the associated workloads of bringing the virtual and physical worlds together, as you saw described in Kawazoe-san's presentation. Examples like digital twin computing, and also network workloads. The N in ION is networks, and there are critical network functions that can run on this data-centric infrastructure. As in one example, we've shown the ability to build radio access network functions on top of OpenShift, composed dynamically out of this data-centric infrastructure. So this is just a great example. And then combined, we have something that we refer to as DCI, data-centric infrastructure as a service, DCI as a service, as well as GPU as a service. Bringing these functionalities together enables RAN workloads on top of AI-enabled infrastructure. So you can imagine a future where we can share hardware resources for different types of workloads composed out of this data-centric infrastructure, DCI. So last year, here at Mobile World Congress, I introduced a 5G RAN edge solution that supports remote direct memory access, or RDMA, over an ION all-photonics network. And this was creating enablement between AI data centers, and it's referenced in the ION Mobile Network Outlook. It's a document, part of the ION Global Forum, great read. And this solution was designed as part of this data-centric infrastructure, partially helping reduce power consumption, and also creating the ability to share these resources that I was describing earlier. And so this year, I wanted to share some new work that we're doing, which is building on the, I know it's a lot of acronyms, the DCI as a service, and GPU as a service capabilities, aggregating mobile front haul traffic, again, using the ION all-photonics network. So what that means is we're showing the ability to sort of schedule workloads or prepare and deliver workloads based on location and power capacity. You saw in Kawazoe-san's that image of smartly distributed data centers. And so here's two different types of solutions, leveraging this composable data-centric infrastructure connected through the all-photonics networks. So I think this is what we're trying to do, is not just show the goals and not just show some of the abstract ideas, but then put into practice how we can bring this to life today. Also, we just announced a collaboration together with Fujitsu. I know I have some peers from Fujitsu here in the audience, collaborating on a vRAN solution. And this vRAN solution is leveraging the inline accelerator, accessible to the DU function in the radio access network. Again, in the context of this shared resource pooling and composable infrastructure. So we can imagine this future world where the same hardware that supports the inline acceleration for radio access networks can also support GPU workloads, so that one set of infrastructure can support multiple workloads which might have different bursty behaviors. And we can then share these resources across these bursty type of workloads, and even consider a future where with that smart data center location, some RAN points of presence may be able to be supported remotely from the fiber connectivity to this GPU as a service type infrastructure that can be repurposed for certain RAN specific functions. So you get a picture of a very distributed world. I like that term, dissolving distance, bringing things closer together through this clever use of technology and the speed of light. So as a result, I think we see this future where we have a lot of flexibility and choice in how we build out our infrastructure to support both AI, which is a big part of our future, as well as the networks and connectivity that bring us all together. Now, in that whole vision, we still have one important challenge. One of the goals here is to reduce power consumption. And we're lacking ways to really understand the power consumption of the infrastructure across each of the different layers, across the networking layer, across the application layer. And to address this, we've just launched the Energy Efficiency and Sustainability Project within the ION Global Forum in collaboration with a lot of partners, Nokia, Infinera, BT, Orange, NTT, KDDI, and many others. This is a really important collaboration. And then this is something that we've also taken some of the same ideas and brought them into the Cloud Native Computing Foundation in the Sustainability Working Group to try to share our ideas that we're developing here in ION Global Forum with open source communities that will be critical developers of the technologies that will support this future. Now, there's also work in the O-RAN Alliance looking at energy consumption in networks. And the difference here is we're all bringing slightly different perspectives. There's the Cloud Native Computing Foundation, very software-centric. There's O-RAN, very RAN-centric. And then there's ION, where we can layer in that all-photonics network and this next-generation data-centric infrastructure together. So this, to me, I think is a really important endeavor that we're working on together. It's through this collaboration that I think we'll be able to really realize this massive reduction in power that we're aiming for across the networks. You see numbers for networks themselves, 2%, 3% of the global electrical capabilities that we have consumed in networks, and then substantially larger growths in AI, so we need to manage that together smartly with this infrastructure. So to me, I think this is the vision that we're working on, and it's beyond 5G and into 6G as we look at the rollouts of this physical infrastructure. And then I thought I would end quickly on just sharing a snapshot of all of the activity we have in terms of POCs conducted across the ION Global Forum. There's one interesting new item here. You see the chip icon, and that is the introduction of photonic electronic convergence. This is a really important capability that allows us to evolve networks without having to do full-scale re-implementations. So in some areas, we will need, we have existing dark fiber, we have optical switches, but we need to extend that into other parts of the computing infrastructure. And the photonic electronic convergence chips can help us evolve our networks without having to throw everything away and start all over. So I think this is a really important piece to pay attention to. It's also something you can check out if you go, if you schedule a half hour to walk back to Hall 2 to the ION Global Forum booth, and you can get some real experience and listen to our booth SMEs tell you about what's happening in that space. So hopefully you'll enjoy the rest of today. There's a lot of important conversations around data centers, and then the revenue side of how do we turn this into value for all of us. So I hope you have a wonderful time here. Thank you for joining us and celebrating our 5th anniversary. And please stay and engage, and we're happy to have you here. Thank you.
Thank you, Chris. I just wanted to elaborate on a couple of points you made, especially when you started around global collaboration. The ION Global Forum started 5 years ago with 3 founding members, NTT, Sony, and Intel, and now we have over 150 leading global technology companies globally collaborating in this effort. So thank you for highlighting that. And I just want to say I've seen Chris speak many times, and he just has a very comfortable way of delivering very complex information. So thank you for doing that. I really appreciate it, and I think the rest of the people here appreciate it as well. So let's move on to our next speaker. Derek Buckley, Microsoft Asia, Managing Director, Telecoms, Media, and Gaming, and also a Board Director of the ION Global Forum. Welcome. Let's give him a hand.
Good afternoon. My name is Derek Buckley. I'm going to talk about a slightly different lens to Chris. I'm going to really talk about, I suppose, the business opportunity, and in particular, some of the challenges or kind of what the world looks like moving forward because of the impact of AI. I lead Microsoft in Asia, working with our most strategic customers, both from a partnership perspective in terms of what they take to market, but also through their adoption of cloud as well. And I get to see the transformation happen in real time. In terms of our investment as Microsoft in cloud, I forgot to move the slides, so just give me 1 second. So in terms of our investment in cloud, we operate over 60 cloud regions, encompassing over 300 data centers spanning the globe. This extensive footprint delivers services in virtually every corner of the globe, ensuring low latency access and compliance with local requirements. The Microsoft Azure, which is our compute platform, includes over 175,000 miles of lit fiber optic and undersea cables, enabling high bandwidth, low latency, and connectivity worldwide. The network interconnects, which there's over 190 edge locations, bring data and services closer to users, minimizing delay. But I suppose things are changing a little bit. And similar to how Koizumi-san spoke, and also Chris, that what we're seeing is that AI is really creating new opportunities and new challenges, I suppose, moving forward. In just a decade, AI has evolved from niche experiments to a transformative force across industries. Breakthroughs in deep learning and generative AI have enabled capabilities once that were science fiction that now can become reality. From AI that converses fluently to systems that drive economic value at unprecedented scale. We're seeing massive compute growth. The compute power fueling AI is rising exponentially. In fact, the compute used by cutting-edge AI models has grown 300,000 times since 2012, an absolutely staggering figure. That's roughly doubling every 3.4 months. This far outpaces traditional IT growth and highlights the extraordinary pace of AI advancement. This new era of AI is poised to deliver massive benefits. Analysts project that AI could boost the global economy by $7 to $10 trillion in the coming years. Such impact underscores why AI is now central to business strategy. If you think about how AI has kind of evolved, it was very much just some small projects, but really what kind of evolved is that it became a board directive, and it became core to a company's strategy. This really kind of shows that organizations are now racing to harness its potential. We've made early investments in AI, supercomputing, and partnerships like the Azure OpenAI service to scale AI. By driving innovation and making advanced AI available globally, Microsoft continues to shape the evolution of AI. In terms of what this means, compute power, AI workloads, especially deep learning and large language models, require high-performance GPUs, TPUs, and AI accelerators rather than traditional CPUs. The need for heterogeneous computing means that data centers must support a mix of processors optimized for different AI tasks. AI inference and training have different computational needs, requiring dynamic resource allocation. And to both Kawazoe-san's point and Chris, this really is impacted from a power and cooling perspective as well. AI hardware is extremely power hungry, with some AI clusters consuming megawatts of power. Efficient liquid cooling or immersion cooling systems are becoming essential to manage the heat generation by AI workloads. The push towards energy efficient AI chips and dynamic workload scheduling is necessary to optimize power consumption. We're also seeing an impact from a storage perspective. AI models require a vast amount of high-speed storage, often in petabyte scale systems. High-performance NVMe, SSDs, and in-memory computing are critical for AI data pipelines. AI workloads benefit from tiered storage, such as fast SSDs for training, object storage for long-term data. From a networking perspective, AI workloads require low latency. They require high bandwidth networking to facilitate fast data transfer between compute nodes. High-speed interconnects, such as 400 gig, 800 gig Ethernet, InfiniBand, and CXL, are becoming more common. AI training clusters often use distributed computing architectures, increasing demand for efficient networking. Scalability and edge AI. So AI applications demand scalable, elastic infrastructure that can expand dynamically. Edge AI processing is increasing, requiring a balance between centralized and distributed edge. It's really changing how cloud looks. Sustainability, the massive power demand of AI is pushing for more sustainable data center designs. Renewable energy sources, AI-driven workload optimization, and carbon-aware computing are gaining traction. Efficient resource utilization, using AI for predictive maintenance and workload scheduling. The list is quite expansive. Security and compliance, AI models and data sets require robust cybersecurity, including zero trust architecture and data encryption, compliance with data sovereignty laws, GDPR, the AI Act, which is really impacting how and where AI workloads are processed. Hence, some large conversations around sovereign AI, sovereign data centers is evolving. And then the future of AI optimized data centers. The next wave of AI-ready data centers will be purpose-built for AI, integrating co-packaged optics, disaggregated computing, and chip-to-chip interconnects. AI will optimize data center operations through predictive analytics, automated cooling, and power management. So if we then look at this, the analyst firm Omdia predicts that by 2025, most networking application traffic will involve AI content generation, curation, or processing. By 2030, nearly 75% of network traffic is expected to incorporate AI. This is really kind of AI applications are then, especially real-time ones that kind of mimic human decision-making, require fast model inference, which is challenging with traditional cloud-based architectures. The emergence of multimodal applications, processing text images, videos, audio, and sensory data, much of it generated at the edge, strains backhaul and backbone networks, posing scalability and cost challenges. Sensitive data used in model training and inference raises privacy concerns. AI really challenges the robustness and reliability of current network designed to tolerate retransmissions. In terms of what this means, and I think it's from a business perspective, really what ION is trying to achieve, you can see that some of those challenges are absolutely solved by ION. It helps kind of bring the next generation of AI to end customers and really kind of help bring AI to every business and every consumer around the globe. The ION network, the ION forum is something that, is developing technology which is in line with the requirements that we're seeing evolve today. So such as ultra-high capacity and ultra-low latency. ION's goals are ambitious to enable networks with 125 times the capacity of today's and 200 times reduction in end-to-end latency. Imagine being able to transfer vast quantities of data at speeds previously deemed impossible. And then secondly, and for the planet, sustainable green networking. This is equally crucial, where the ION vision, targeting 100 times improvement in power efficiency for network infrastructure, is going to have a huge impact. Okay, thank you very much for that. Any kind of questions, I'm very happy to answer them after the session. And please stop by the booth to talk to both the board members and executives and members and non-members so we can network together. Thank you very much.
Thank you, Derek. Excellent coverage of a very important topic, which we all know and hear about all the time, is AI. And I wanted to mention how when the idea of a photonics-based network infrastructure was first developed by Kawazoe-san and the team in 2019, this was before we knew what was coming with AI. Yes, we knew there was a lot of data demands coming on the network, but imagine now not having this ION Global Forum, because not only was that prediction that we're going to need new infrastructure correct, but today it's critical. So I'm really happy and pleased to see the groups come together to focus on what is really a critical issue, both for AI, but also for the planet, which Derek, you've mentioned very, very eloquently. Thank you. All right, let's move on. Thank you for hanging in. We got a lot of content still to go. So here we go. I'd like to introduce Dr. Hayashi from KDDI Corporation, GM Infrastructure Technology Research and Board Director of the ION Global Forum. Please welcome Dr. Hayashi.
Okay, thank you, Vito, for a kind introduction. I'm Michiaki Hayashi with KDDI. Yeah, I think one of the important role of ION Global Forum is developing the ecosystem of All-Photonic Network, APN. So I'm gonna tell you two things in this presentation. One is the background of why KDDI is doing this community activity. The second one is actually how we can develop the ecosystem. This diagram shows kind of a metaphor to explain KDDI's business strategy. Yes, by using the satellite orbit. And actually, we have providing a variety of business segments like healthcare, mobility, or space communication, or whatever. But if you look at the center of the orbit, is 5G, data-driven, and Gen AI. So that is some of the telecommunication business. And if you look at the 5G and Gen AI, those are very hungry about bandwidth and the speed of light. So in order to achieve those businesses, APN surely help achieve those business, I believe. Indeed, left-hand side is a vision of the KDDI's platform business. And if you look at the middle, we have an all-photonic network that connects various types of devices. And APN provide support cyberspace. You can see some platform is typically AI data center. And indeed, we are rolling out a variety of type of all-photonic network technology. And this example shows Metro Core APN rolling out in the national scale with the help of Fujitsu and Cisco technologies. By using this technology, we successfully reduced 40% of energy of this infrastructure compared to the conventional one. And we will complete this rollout by the end of 2028, hopefully. The name of the business platform of KDDI is called Wacom Cross. This name, it comes from Japanese word Wacom Yosai, meaning following the global standard, but adding a Japanese value for worldwide impact. So by the way, how many people know about Wacom Cross? Oh, good number, thank you. Please remember, Wacom Cross is AI-driven business platform for various types of business segments, such as mobility, retail, logistics, and so on. Okay, let's move on to the second part, how we can actually develop the ecosystem of APN. I think this is a very important role of ION Global Forum. Okay, so actually inside of the ION Global Forum, we are discussing many aspects, but I would like to introduce two approaches. First one is uplifting ION Global Forum outcome, such as use cases, technical documents, such kind of output to procurement specification proof ones. Indeed, we started discussion to collaborate with other outside organizations who make a de jure standardization specification or implementation agreement. So the kind of activity is connected to enhance the ecosystem, I believe. I will explain the concrete example of number one after this. And the second one is relatively new activity. But we can create more opportunity for edgy use cases or edgy users, such as startups or university students. Maybe we can create industry events or Plugfest or providing test bed so that we can discuss our edge use cases. Okay, regarding number one approach, if it comes to APN technology, ITU has been a champion of the optical transport for a long time. And I believe APN is a new type of optical network based on the kind of heritage. So we actually started the discussion in the ITUT about the concept of IO Global Forum. And we started discussion in the last year, and KDDI, NTT, Sony, NEC, Fujitsu, Oki, Sumitomo Electric collaborated to propose to create a new work item in ITUT. Actually, there was a big discussions and even concerns from many countries, but we did a careful discussion in the Geneva, and we successfully established. We agreed establishment of this new work item. So we started creating a new recommendation based on the ION Global Forum concept. Okay, finally, you may think, what is exactly the APN technology is? So don't worry, we are demonstrating many technology. And this is just one example. But in ION Global Forum booth, we are demonstrating multi-core optical fiber technology developed by KDDI with the fiber makers. So conventionally, optical fiber has only one waveguide as shown in the right-hand side. But by using a multi-core optical technology, we can have many optical waveguides. This kind of technology enables very huge bandwidth communication between AI data center or new applications. So please visit ION Global Forum booth, and maybe hopefully I can explain this technology. Okay, this is my introduction of ION Global Forum. Thank you.
Thank you, Dr. Hayashi. This is a real-life case example where the collaboration of two companies like KDDI and NTT and others. KDDI is a formidable and respected competitor to NTT Docomo in Japan, and yet here we are together trying to create value for the next generation of networks that we all said and know that we're going to need. So thank you, KDDI, for your contribution to the ION Global Forum. We really appreciate it. All right, we have two more speakers, and those two start with Ralph Rotschat, Ciena, VP Global Sales Engineering, and Board Director of the ION Global Forum. Thank you. Let's give them a hand. The green button.
Thank you all for joining us today. We've been going for almost an hour, so I'm going to ask you to just all stand up, just stretch your legs a little bit, and then sit down again. Okay, so to give you an idea of what an APN can do, in the 3 seconds it took you to stand up and sit down, we could have transmitted the entire contents of a 10 terabyte hard drive from Tokyo to LA. Okay, so the capacity of the APNs is really driving everything that we can do in the world. That's on a single fiber of what Hayashi-san just showed. On a single fiber pair, you could drive all of that capacity in just a few seconds. Now, why do you need to do that? There's a lot of things happening, and as you saw, the vision that Kawazoe-san had when they started ION in 2020 was looking at how we could continue to sustain that growth without blowing up the capacity, the energy that's required. My presentation is going to be a little bit about that sustainability, that efficiency that we're driving in the APN, and how ION is really helping us to understand how to do that. My name is Ralph Rotschat. I'm part of Ciena. I work in the sales engineering organization. I'm the head of the global organization. And I have the fortune of sitting in Ottawa, which was the birthplace of coherent optics. And I'm going to talk a little bit, on the one hand, about the detailed technology behind that. On the other, I'm going to talk about what the implications are and what's really happening across the globe. So if we look at everything that's happening in ION, there's so many different aspects to it. I joined ION as a board member about a year ago, and I'm really impressed by the diversity of different aspects that are being discussed. We have members like Red Hat, service providers, and there's so many different areas. Chris used the same chart to talk about the different things. If you look at Ciena, we have a particular area of focuses. We have areas around things like security. We have things that we're looking at like digital twin. This is an interesting area, especially for us, in one specific focused area inside of ION, which is the network digital twin. If we look at that and we look at the capabilities and everything that we have in terms of open networking, all of this is important to Ciena, and we're really happy to engage with service providers. And as pointed out, that we also have competitors. We have people like Nokia and different companies, Fujitsu, NEC, that participate, and we all collaborate to understand how we can drive this forward. Now, the APN itself is obviously the foundation of what Ciena does, and we've been working on this, for the last 40 years, trying to drive optical networks and move forward. The participation in growing, and the idea of having an all-photonic network, a network that starts as optics and finishes as optics, is something that is really been inspirational for us as well. And we've been driving a lot of the aspects around the efficiency. I said I was going to talk about sustainability. Part of it has been, how do we get more out of the same amount of content? So how do we get more out of the existing fibers? A lot of these fibers were installed, by NTT in Japan 40 years ago. Like, equipment that was put in the ground 40 years ago is still being used. And how do we do that? By every generation of photonic network equipment that we connect to the ends of it, we boost up the capacity. We come up with new technology. We come up with WDM. We come up with coherent interfaces. We drive a lot of that technology. And the beauty of the ION Global Forum is that it captures all of that and brings it into a format that you can read, and you can look at the architecture and really understand how a network like this is built. What are the building blocks? I'm going to talk about some things that are very focused and very specific. An APNT. What is an APNT? It's a transponder. It's something that connects 2 points in the network. These are things that, if you dig into the ION Global Forum, the documents and the stuff that's open to the public, you can see a lot of really great content. At the same time, in driving the capacity, so like I said, that ability to send so much capacity over fibers that were installed 40 years ago, to grow that capacity, has also been a way of making sure that as we increase that capacity, we're not increasing the amount of energy that's required. So that's something that the Photonic Network Promise has made. That's part of what we've talked about. Those are the 3 objectives: reduce latency, being able to send things faster, higher capacity, and more efficiency. And those foundational blocks existed before the explosion of AI. But it's been able to address the challenge of AI by continuing to deliver those capabilities. So if we look at beyond that sustainability, I talked about different ideas, and Chris was talking about the focus on sustainability and what we can do in terms of environmental impact. At Ciena, I took this chart because I think it's very applicable, and one of the things that we do at ION is we share information. So we do presentations, we talk about different things, and this is an example of something that I would bring to the ION. We talk about how beyond the energy efficiency we can gain by delivering new technology, how can we leverage the way we design products to ensure that there's less impact? How can we make sure that the products that we deploy remain in the network for as long as possible? So, for example, in an APN network, the photonic layer itself, the amplifiers, the ROADMs, all of these systems are designed to be able to carry multiple generations of transponders. And this is a fundamental part of the APN all-optical network architecture. So a lot of that is really a great aspect. Reducing packaging needs, being able to drive everything in terms of reduced sparing. If you've ever worked in a network, you know that certain things fail, and it's very important to have spare equipment on site. If we can reduce the amount of sparing equipment that's required, that's a good way of saving in terms of the amount of equipment that we have to build. We have efficiency around how do you identify exactly where the fault is. So beyond the benefit of having a faster repair after a fault occurs, there's also the advantage that we spend less time driving around looking for that fault. There's less energy, there's less people, less truck rolls. And so, instrumenting the system, making sure that we get the most out of that network is very important. Another aspect is how, in the engineering, in the detailed engineering of a photonic network, you need to understand what is the maximum capacity that you can run from one end to the other. And part of that requires the best simulation tools, the best ability to instrument the network. And so as we've gone forward, and this is all described in the architecture documents of the APN, there's a detailed information about how to identify where faults are occurring, how to optimize links to make sure that we're transmitting the maximum amount of capacity across that link at any given moment. So all of these things that we talked about really drive everything that's happening, and everything that we can do to reduce the amount of energy is extremely important. Another aspect, when we start looking at how that translates into this new world of AI, there are many different things happening with data centers. So data centers require, all kinds of capacity, and part of the challenge with AI is that it is very energy hungry. And so in the past, data centers were brought together and centralized in a certain area for efficiencies, for scale, but now data centers are being distributed in areas where energy is available. And in order to connect those energy centers together, the APN network provides that capability, the scale and the distance, and part of it is in between those locations. So you can imagine these data centers distributed around a city, around a country, across the world. There are intermediate sites that are required. And part of what we're working on is making sure that those intermediate sites are also very efficient, because those sites have existed for a long time, and they have limited capacity in terms of power and limited capacity in terms of space. So connecting these different data centers together is very important. And then the other aspect is that there are varying needs. There are different areas. So if we talk about the data centers that are being used for training, for AI training, they are distributed, they're very large. But an important part of making AI more scalable is the use of inference centers. And so, many people, if you're working in AI, you understand exactly what this is. If you're not familiar with the term inference center, it's a little bit like what caching was to video distribution. So a company like Netflix started off with all of their data centralized. After a while, they realized it was more efficient to create caching centers around the world. And that's the equivalent of what an inference center is for an AI. It does a different function, but it has the same ability of providing a distributed kind of functionality and still providing the same capabilities. The other thing is that enterprises are also very important and have really driven a lot of different capabilities and the interest in things. And you're going to hear about this more in some of the detailed sessions that are coming up. But the whole idea of GPU as a service. These are things that have started to gain interest. And the whole point of the APN was to develop an architecture that could support all of these different varying applications. And I think that's one of the big successes of the ION Global Forum is in having established that baseline that can be used going forward. Now, I'm going to dig into a little bit more detail. This is the next level of detail. And one of the things, if you looked at that curve that I showed you before, where we increased the speed of individual wavelengths. So a wavelength on a fiber, you can have multiple wavelengths on a single fiber, and now the highest amount of capacity you can have on a single wavelength is 1.6 terabits. So that's the technology that at Ciena we've been able to develop. And that takes an integrated function. So if you look on the right, you have that integrated circuit board that is a very highly specialized capability that drives the absolute maximum capacity that you can get out of a fiber. Now, in a network, and I refer to the APNT because in the ION terminology, an APNT is the terminal that provides that wavelength connectivity. There are different options, and some of the options allow you to understand based on what is the range and what is the reach, and what are the importance. We talked about latency and the importance of latency. So if we look at the one on the far right, this requires highly sophisticated digital signal processing, which adds a little bit of latency. Now, if you're crossing the Pacific Ocean, that relative amount of latency is not that significant. So adding, a few microseconds of processing across a link that takes 10 to 20 milliseconds to transmit the light is not a big deal. Inside of a data center, microseconds count. And so if you look at the pluggables, which are a much more form factor, a smaller form factor, a much more condensed way of delivering a wavelength, inside of a data center, for example, we're developing interfaces that are down to a single microsecond of latency. So it's important to have those options, and that's one of the things that you see if you dig into the ION architecture. You'll see that all of these different kind of options are discussed and how you can actually leverage them to achieve the connectivity across networks that's required to address things like AI. Now, the next, this shows a little bit of detail. We can talk about how options for the APNT is there. One of the things that is now, and a lot of this technology has been developed and incorporated into the architecture and is referenced, but some of the things that are starting to be discussed inside of the different forums include much more sophisticated things. So if you look at the bottom right, hollow core fiber is something that we're looking at as well, and we heard earlier about the multi-core fiber. There's different technologies involved in fiber. Now, one of the things that I talked about was being able to leverage the installed base, that fiber, the thousands and millions of kilometers of fiber that have been installed. We are reaching a point where we are exhausting the capacity. We used to think that the capacity of a fiber was infinite, but through our technology, we've reached the point where we've reached a limit, a physical limit on how much you can transmit over existing traditional fiber. And so we have to deploy more fiber. If you look at companies across the world, there's a scramble to get more traditional fiber installed across the world. But there are also new fiber types that are being looked at, and that's one of the things that is being discussed, and we have different presentations and things like that throughout the different forums at ION. And if you look at the top left, I talked about how the sites in between two locations, in between two data centers, in between two cities, there are intermediate sites, and these are huts. They're a little house, like a little building on the side of a railroad track or somewhere else. And one of the things is that that site is limited. And so what we're trying to do is using packaging techniques and different type of capabilities. We're talking about things that are described as multi-rail. So multi-rail meaning that you're supporting multiple fibers on a single platform. And this allows us to get more and more into those intermediate sites. So at every point in the network, there's a different type of effort being made to increase the capacity, and that's, as we're racing to continue to feed the bandwidth requirements for AI, every single one of these different dimensions is important. The other thing that if you look at CNL, if you're familiar with photonic systems, you know that the C-band it's the spectrum in the fiber, the color, the light that's available was traditionally used at the beginning. L-band was an expansion. And basically that means we're going into other bands. If you're in wireless domain, then you know about what bands mean, and you know how access to new spectrum is an important thing. There's cost that comes with that. And that's one of the things, one of the challenges that we're trying to address is how we can access different bands throughout the network. So all of these things are really important. You know, you know, I've kind of tried to, on the one hand, give you a high-level view of how ION is looking at some of the capabilities of driving efficiency and how over the last 5 years that's changed, but the underlying architecture of the network, the APNs, has continued to remain valid. On the other hand, I've tried to show you some of the really detailed technical discussions, and I think, you know, that's one of the beauties of the ION Global Forum, is that it allows you to achieve an understanding and a reference architecture for many different aspects, including some areas that are just emerging, like network digital twin and security. All of these things are evolving, and I think there's a lot of interest. At Siena, we don't even touch on everything that's inside of ION Global Forum, and we get a lot of value out of it. So I just wanted to go through that, and thank you all for joining. We have a lot more technical. We're going to dive into this in a lot more technical detail, and I'm going to pass it on to the next speaker.
Thank you, Ralph. We really appreciate that, and also your focus on sustainability. One of the things that sometimes is overlooked is we talk about the demand for power that's being driven by AI, and we're building more nuclear, and we're building more renewable, and someday fusion. But the ION Global Forum technologies can actually do the opposite, which is reduce the demand needed for the same or more power capacity in delivering AI. So both of those have to happen at the same time, and I think the ION Global Forum is a leader in doing that by some of the examples that you use, so thank you for that. I would like to introduce, last but not least, the most famous Dr. Gonzalo Camarillo, Ericsson Head of Implementation Components and Marketing Steering Committee Chair of the ION Global Forum. Please join me in welcoming Dr. Camarillo.
Thank you very much. Usually, when we give this type of presentations, we do it the other way around. I start by introducing the forum, giving like the top-down view of what the activities of the forum are, how we are basically structuring the work, and then we have different presentations touching different parts of the forum, as you have seen. This time we are trying something different, which is more a bottom-up approach. So you have seen a few presentations explaining different sides of what the forum is about, and also how members actually engage in different ways with the ION Global Forum, the benefits they derive from that. And now I'm going to try to wrap it up together and provide you the big picture of how the forum is structured and how we work. So let's see what works best. Feel free to give us feedback, and so that we can prepare for future presentations as well. As we said, we have, by the way, if you haven't noticed, the 5-year anniversary. So we have a special logo. Our anniversary was in January, as was mentioned several times. We are actually very proud of that. So as you can see here, we have the vision. We started 5 years ago when the forum was created. The vision was basically 2030. Now 2030 doesn't seem to be so far away, but at the time was a 10-year journey. And the mission, so the vision was basically captured in a document, very inspirational document. You can go there and read it, even though it has been revised a couple of times. But our mission is to build a communication infrastructure for the future by leading the transition from electronics to photonics. So you will see this concept, this motto, this slogan repeated many times. The idea is to drive the revolution from electronics to photonics. These numbers, they have been actually appearing at least in 3 presentations. Kawasoe-san was showing them first. And this was kind of the promise that the forum was making. Lower consumption, higher transmission capacity, and lower end-to-end latency. The idea is, given what the APN technology can provide you with, the ION Global Forum is working on more technologies, as for example we saw in the slide that both Chris and Ralph were using. But we are best known for the APN, and all the other technologies are supporting basically the APN in a way. So once you have that, what can you achieve with that? And we have what we call pillars. The first one is the data-driven age. Kawasoe-san touched upon that. We have seen an incremental increase in traffic, not only on the internet, as Kawasoe-san mentioned, but also mobile networks. For example, in Tokyo after COVID, the increase in traffic was incredible. We need to cope with that. So everything we do in the forum is basically driven by data. The resiliency part, we talked about avoiding single points of failure. And by being able to distribute infrastructure with using, again, APNs, we are able to distribute and achieve basically resiliency. Sustainability, it's also achieved by avoiding single points of failure, or in this case, hotspots for energy, by being able to, as it was tackled before in one of the presentations, distributing data centers so that they are closer to where the energy is produced. In that sense, instead of having a very large data center, you can have several distributed smaller ones with less energy requirements and better access to sustainable energy. So those are the pillars that we basically hit all the time when we present the forum, because those are our guiding stars when we are working. And then I'm gonna explain very briefly our ways of working, because I think this is important, because the ways of working actually, they are key in the results that we are producing, and basically they will help us achieve the impact we are hoping to achieve. So first of all, as you can see there, we always start with use cases. So we start defining a use case, and several of them were mentioned before, like remote GPUs, remote video production. There are several ones. You have them then here, down there. I will talk about them later. We derive, once we have a use case, derive the requirements that use case, that particular use case, puts on technology. And once we have that, and this is interesting, we develop the technical architectures, the blueprints, and prototype them. This is the POCs, the proof of concept prototypes that we have been working on. Those POCs, they basically allow us to understand if our assumptions and the requirements we were identifying, they are real and they can be implemented. This is an iterative process. We go back to the drawing board with the lessons learned from the prototypes, and we end up basically with the technical architecture that is refined and ready for deployment. Something we get a lot of questions about is what is the role of the ION Global Forum when we say we develop technical architectures, concepts, blueprints. So we recognize that there's industry recognized centers of competence, like, if you want to develop, for example, an encryption algorithm, you would go to the IETF, an algorithm protocol, you would go to the IETF. You may go to 3GPP if you are trying to basically introduce changes in the architecture of a mobile network, and so on and so forth. You have IEEE, you have ITU, it was mentioned before. So to be clear, the ION Global Forum is not trying to compete or replace any of that. So we use the technologies generated and created by those organizations. We generate blueprints, we explain how you have to use it together to achieve a use case. Of course, sometimes the technologies that these organizations are developing or standardizing or open sourcing, they don't meet the requirements that we basically derive from the use cases. In those cases, we talk to those organizations and try to get our requirements in their processes so that the standards they develop or the open source, whatever artifact they are developing, it meets our requirements. So we do both. And in fact, we have a liaison working group. I see the chair, Hans, back there, that he's handling the relationship with those recognized SDOs so that we have these communication channels open at all times. So having explained how we work and the types of artifacts we produced, I think it's interesting because that was touched upon several times as well, the types of members we have. And members, again, we are over 150 members, as it was said before. That's quite impressive. And I always say our membership is diverse, at least in three important axes, in three important dimensions. The first one is, as you can see there, and you saw just by the speakers, we have user companies, we have research institutions, we have equipment vendors, operators, etc. So we cover all the roles in the industry. The goal of the ION Global Forum is to achieve deployments at the end of the day, so commercial deployments are at the end of the road, and for that we need all those diverse members. As you can see, you can mirror actually the ways of working I was describing there and the types of members. So for example, if you have user companies like a financial institution, they will be actually very active in the phase where we are defining use cases. Maybe in the phase when we are prototyping, it will be an equipment vendor, and then how to understand how to operate those technologies, it will be an operator. So we need those roles in order to basically implement the ways of working as we envision them. Then, in addition to that, another dimension in which we are very diverse as well is industry verticals. As you will see, we have different use cases, and different use cases, they address complete different industry verticals. So we can have there, for example, financial institutions, and there we can have video production. As you can see, very different industry verticals. We need members from both to understand requirements and understand the use cases. And then market areas. This is geography. As you know, we are extremely strong in Asia, but also we have strong companies in Europe. I myself work for Ericsson, for example, and in North America, several of the previous speakers, they work for companies based in North America. So very diverse membership. And I liked the point that several of you were making before, which is that competitors come here to collaborate and create something that is basically good for the ecosystem. So that's actually a very good property of the ION Global Forum. And finally, almost finally, I have one more slide, but I will go over that very briefly. We are using the technology adoption life cycle of Geoffrey Moore, which is basically the two basically groups that we are concerned with is early adopters and early majority. And the famous, Crossing the Chasm was originally the original book that was written. It's about how to address early adopters and then move to the early majority. And how to address those types of customers is completely different. Early adopters, they are interested in technology. They would implement anything because it's just, for the sake of technology. It's cool to implement it. They would jump and do it. While early adopters, they are actually looking at things from a pragmatic point of view. They are pragmatists. So if the technology is useful, they will use it. If not, it doesn't matter that it's a new technology, they will not jump into that. That's why the use cases we are working on, we call them early adoption use cases, because now we are trying to basically first address early adoption. And as I said before, we have now video production, connecting financial institutions, remote GPOs, and mobile front haul. Since we're going to be talking about that in the panels, I will not go over them, but just keep in mind that we have these early adoption use cases, and then everything else we call them future-looking use cases. And lastly, going to the last slide, this is just to give you a very quick glance, basically, about how the ION Global Forum is structured. We have the board, and as you have seen, several of the speakers before, they are part of the board. And then we have the Marketing Steering Committee, and myself chair that committee. And then we have the Vision Steering Committee and the Technology. As you can see, it mirrors perfectly the ways of working I described. Vision works on use cases, then the Technology Steering Committee is working on the technologies, taking requirements from the use cases, and then we basically are the Marketing Steering Committee trying to promote the activities of the forum. With that, I would like to wrap up. Thank you, everyone, and give the floor back to Vito. Thank you.
Thank you, Gonzalo. Nobody knows the ION Global Forum better than Dr. Camarillo, and he did a good job covering a lot of ground there. But we want to engage further with members and recruit new members to this initiative, which I think, as I've said before, is not just correct, but critical.